Hello, in this video I'm going to talk about binomial expansion. Binomial expansion. Right, a binomial is an expression, basically an expression that looks like this. Say some number plus some other number times x. That's a binomial. Now if we have additional terms like x squared and so on, right? Like x squared is what you would see in a quadratic equation, and if you have higher powers of x, we call that a polynomial. So in this case, we are, for this binomial expansion, we mainly want to look at this simple case where we have just a 1 plus x. We just want to look at this binomial, this simple expression, and the expansion here refers to what happens when we raise this to some power of n. So n can be any whole number, like 1, 2, 3, 4, and so on. The binomial expansion is actually a formula that allows us to write down the expansion of this expression for any whole number n. Okay, so I'm just going to write out the formula directly, and then I'm going to explain how it comes about. Now in this formula, that's the first term is just 1. The second term is nx, n coming from the power here, and x is this number. The third term is n times n bracket n minus 1 over 2 times x squared, plus, and the next term is n minus 1 n minus 2 over 3 factorial times x cubed plus dot 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 and so on. Now you might already be able to see a pattern here. Let me just write this as 2 factorial. The pattern here is that as you go from, maybe I can even write that as 1 over 1 factorial, which is just 1 actually. As you go from say the second term to the third term, you include this bracket n minus 1, and when you go to the next term, you have a bracket n minus 2, and so on. And at the bottom, you have 1 factorial in the second term. Third term is 2 factorial, then 3 factorial, and the next one should be 4 factorial. So there's already a pattern that is emerging from here. So this, if you're seeing this for the first time, it will look quite complicated, and it's difficult to understand why this 1 plus x to the power of n turns into something like this. And and then also, where exactly does this go until? Okay, so I have a dot 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 here. Does it stop? Yes, it does stop. It stops when we reach x to the power of n. Okay, now that is also a bit tricky to understand. Shouldn't there be some complicated formula down here for the number in front of x to the power of n? There can be, we can write this down, a corresponding expression down here, but turns out that it would be equal to 1, as we'll see afterwards. Right, so to get a better idea of how this comes about, let me start with the simpler case when n is equal to 2. We have 1 plus x squared. If I want to find the expansion for this, okay, we know how to do it. You might even have already remembered the formula, but let me just work it out slowly so that we can start to understand how to extend this the method here to higher powers. So if I want to expand this, what would I do? Okay, I would look at each term in a bracket and multiply it by each term in the other bracket. So I would do 1 times 1, that gives me 1, and then I'll do 1 times x, okay, that gives me x, and I'll go to the next term. I do x times 1, gives me x, and I'll do x times x, that gives me x squared. Then if I add all this up, or if I simplify it, I'll get 1 plus, so x plus x is 2, 1 plus 2x plus x squared. So this is the expansion. This is the expansion, and since as I've mentioned, we call this expression in the bracket, the 1 plus x, we call this a binomial. Since we call this a binomial, and since this is an expansion, this is the result of expanding this binomial squared expansion. So therefore this answer down here is a binomial expansion. So we have just written out our first binomial expansion in this video anyway. And this is something that you would already know if you have learned about quadratic equations. Okay. Now, let me now do something let me now do it in a slightly different way, or rather think about it in a slightly different way. Okay, I'm going to start with the same expression, 1 plus x, 1 plus x. Now from what I've described just now about, you know, how I multiplied out and get all the 4 terms down here, from what I described here, I'm obviously picking out pairs of terms from the 2 brackets. So I would pick one term from here, either the 1 or x, and then I'll pair it up with one term that I pick from the other bracket. Okay, so and what you can see here is that I ended up with 4 possible ways of picking the 1 or the x. So if I pick 1 and 1, I got this. I pick 1 and x, I got that. Pick x and 1, I got that. I pick x and x, I got that. So I can start thinking about maybe I can actually think of a faster way or easier way to get to the answer if I start thinking about how many ways I can, pick the pairs. Like for example, if I want to um, let's say if I want to pick a pair that contains no x. Alright, if you look through these four terms, so these three contain x, but that one does not. So let me think about it this way: if I want to pick if I want to pick a pair, if I want to pick a pair that has no x, if that's what I want to do, how many ways can I do it? Right, there's only one way actually. There's only one way. If you try and do it any other way, there will always be an x involved. Okay, so I can only do it by picking the 1 here and picking a 1 there. So if I want to pick a pair that has no x, there's only one way to do it, and that would be that would be picking the 1 and the 1 to give me 1. Okay, now what if I want to pick a pair that contains just one x, or one factor of x. Just contain one x. So if I look at this, right, let's say I pick the 1 from here, then I have to pick an x from there, right? I can't pick a 1 from here and a 1 from here because then this would not give me any x. So if I want exactly one x, I can do it by picking a 1 from here and an x from there. So that's one way to do it. Now the other way to do it is I can pick an x from here and a 1 from there. So that's another way. But I can't pick an x from here and an x from here because that would give me an x squared. That would give me 2 factors of x. So that's not good. So there are two ways to do it. I can either pick the 1 from here and an x from here, okay, or an x from here and a 1 from here. So there are two ways that I can do it. Okay, and if I just want to pick a pair that contains just one factor of x, it would always be just x times a 1, or the x here times the 1 there. So each pair would multiply to give me just x. But since there are two ways I can do it, I would end up with 2x. Okay, so this gives me 2x, which is actually this. Alright, the 1 there would be the 1 here. And finally, if I want to pick a pair that contains 2 factors of x, and well, from what I've described up to now, you can see that this is the only way I can do it. I have to pick an x from this bracket and an x from that bracket. Okay, if I do it any other way, I would end up with either this or this. So there's only one way I can do it, x here and x here, just the one way. Okay, and the pair gives me an x squared, and since there's only one way to do it, I would end up with just one x squared, which is this. So if I think of it this way, I would end up with this plus this plus this, which gives me the answer directly, okay, without actually having to go through this step. Now my description so far is quite long actually compared to the time it took me to work through this simply by writing down all the possible combinations. So what I've done is that what I was trying to do here instead is to think in terms of how many ways I can pick either no x or one factor of x or two factors of x. Now it took me quite a while to describe that, but once we get the idea, it can get faster. In fact, it can get very fast. Alright, we can work out a very efficient way of writing out the expansion, even when the power is more than 2.